not long ago. The idea of a robot that could think, learn, and move, just like a human, was pure science fiction. We saw it in movies, we read it in books, but in the real world, it seemed like a distant dream. But what if I told you that dream is rapidly becoming our reality? Today, we're diving deep into a project that could fundamentally reshape our world. The Tesla Optimus. This isn't just another robot. This is a humanoid, designed by one of the most ambitious tech companies on the planet. Its goal: to take on the tasks that are dangerous, repetitive, and boring for humans, freeing us up to pursue more creative and meaningful work. But how does it work? What can it actually do? And what does its arrival mean for all of us? Let's start with what we've seen so far. From its initial reveal, where a person in a suit danced on stage, to the latest demonstrations, the progress has been staggering. We've seen Optimus prototypes carefully picking up objects, sorting items with increasing dexterity, and even performing a yoga squat. It might sound simple, but for a machine, this level of balance and control is a monumental achievement. The latest generation, Optimus Hendos, is lighter, faster, and more capable than its predecessors. It walks more naturally, its hands have more sensitive tactile sensors, and its movements are smoother, more human-like. So, what's the magic behind it? The secret sauce is Tesla's deep expertise in artificial intelligence. The same AI that powers Tesla's autopilot and full self-driving capabilities in its cars is the brain behind Think about it. A Tesla vehicle navigates a complex, unpredictable world every single day. It has to understand its environment, predict the actions of other drivers and pedestrians, and make split-second decisions. This is all accomplished through a massive neural network, trained on billions of miles of real-world driving data. Optimus leverages this very same technology. It uses cameras as its eyes to see and interpret the world in 3D space. It learns how to perform tasks, not by being programmed line by line, but by observing humans. This is a crucial difference. Engineers can show Optimus how to fold a shirt, and through a process called imitation learning, the robot figures out the necessary movements and motor controls to replicate the action. This end-to-end neural network approach means Optimus can learn tasks much faster and more intuitively than traditional robots. It's not just following a rigid script, it's developing a genuine understanding of the physical world. The hardware is just as impressive. Every part of Optimus, from the actuators that act as muscles to the custom-designed sensors in its fingertips, is engineered by Tesla. This vertical integration allows for rapid iteration and improvement. The hands, for example, are a marvel of engineering. They need to be strong enough to lift heavy objects, but gentle enough to handle a fragile egg. The latest version has sensors on every fingertip, giving it a sense of touch that allows it to manipulate objects with incredible precision. Its balance is maintained by a complex system of sensors and motors, constantly making micro-adjustments to stay upright, just like our own bodies do without us even thinking about it. Now, let's talk about the big question. What will Optimus actually do? Elon Musk envisions a future where fleets of these robots work in factories, warehouses, and eventually, even our homes. Imagine a factory floor where Optimus robots are performing the physically demanding and repetitive tasks on the assembly line. This could dramatically increase production efficiency and, more importantly, reduce workplace injuries for human workers. Tesla plans to be its own first customer, deploying Optimus in its own gigafactories. To prove its capabilities and refine its design, the potential applications are almost limitless. In logistics, they could load and unload trucks, sort packages, and manage inventory. In healthcare, they could assist nurses with lifting patients or delivering supplies. In disaster relief, they could venture into areas too dangerous for humans to search for survivors or clear debris. And yes, eventually, they could come into our homes, helping with chores like cooking, cleaning, and laundry. Musk has even stated that he believes in the long run, the demand for humanoid robots could be in the tens of billions. He sees a future of abundance, where robots handle the labor, and the economy is completely transformed. Of course, this vision brings up another, more pressing question. What about our jobs? The fear that robots will take over human employment is as old as automation itself, and it's a valid concern. If a robot can do a job cheaper, faster, and more safely than a person, what happens to that person's livelihood? The history of technology shows us that while some jobs are eliminated, new ones are always created. When the automobile replaced the horse-drawn carriage, the jobs of blacksmiths and stable hands disappeared. But new jobs, like auto mechanics, factory workers, and highway construction crews emerged. The proponents of Optimus argue that the same will happen here. By automating manual labor, we free up human potential to focus on roles that require creativity, critical thinking, social intelligence, and complex problem-solving skills that are, for now, uniquely human. We might see a boom in jobs related to designing, maintaining, and managing these robotic workforces. Programmers, robotic technicians, AI ethicists, and experienced designers will be in high demand. The economic shift could also lead to concepts like a universal basic income, or UBI, becoming a more serious topic of conversation. If robots are generating immense wealth through their labor, a system could be put in place to distribute that wealth, ensuring everyone has a basic standard of living, regardless of their employment status. This would allow people to pursue education, art, entrepreneurship, or simply spend more time with their families. It's a radical idea, but in a world with near limitless labor, the very definition of work might need to change. However, the transition won't be without challenges. There is the immense technical hurdle of creating a robot that is truly general purpose and can operate safely and reliably in unstructured human environments. A factory is one thing, a chaotic home with pets and children is another entirely. Safety is paramount. How do we ensure a powerful robot never harms a human, intentionally or accidentally? This brings up the classic Asimov's laws of robotics dilemma, which science fiction has explored for decades. In the real world, this will require incredibly robust software, foolproof safety protocols, and perhaps even new laws and regulations governing AI and robotics. Then there's the societal and ethical dimension. How do we prevent this technology from increasing inequality? If only large corporations can afford these robots, the gap between the rich and poor could widen. How do we ensure a robot tax or other mechanisms are in place to fund social safety nets and retraining programs for displaced workers? These are not just technical questions, they are deep philosophical and political questions that society will need to answer together. Looking at the broader landscape, Tesla is not alone in this race. Companies like Boston Dynamics, with their incredible Atlas robot, Figure AI, and several others, are all pushing the boundaries of what's possible. This competition is healthy. It accelerates innovation and forces everyone to build better, safer products. But Tesla's unique advantage lies in its massive trove of real-world AI data from its vehicle fleet, and its proven ability to scale manufacturing at an unprecedented rate. If anyone can take a humanoid robot from a lab prototype to a mass-market product, it's arguably Tesla. So, what does the future hold? In the next 5 to 10 years, we can expect to see Optimus and other humanoid robots becoming a common sight in controlled environments like factories and warehouses. They will get smarter, more agile, and more capable with each passing year. As the technology matures and costs come down, they will begin to venture out into more public-facing roles in retail, hospitality, and logistics. The vision is a future where humanity is elevated. A future where we are no longer defined by the toil of our labor, but by the strength of our creativity, the depth of our relationships, and the reach of our ambitions. The journey to get there will be complex and filled with debate. But the development of humanoid robots like the Tesla Optimus marks a pivotal moment in our history. It's not just the dawn of a new machine, it's the dawn of a new age for humanity. We are standing at a crossroads, and the decisions we make today about how we develop and integrate this technology will shape the world for generations to come. The robot revolution is no longer a matter of if, but when. And it's happening faster than any of us ever imagined. Thanks for watching. If you found this journey into the future of robotics fascinating, be sure to hit that like button and subscribe for more deep dives into the technology that is shaping our world. Let us know in the comments what you think. Are you excited or worried about the rise of humanoid robots? We'd love to hear your thoughts. See you in the next one.